This Zoom session is being brought to you by the Fractal Almond Octaves S. Okay, for today, I'll be discussing 5.6 and 5.7, which are extra credit on the homework. And this is the last meeting of the class. Homework due by Friday midnight, and we proceed from there. Okay, well, today, 5.6. Hello. 5.6 vectors in space, and 5.7 cross product. Now, okay, this will be about three-dimensional vectors with dimensions a by b by c. A is the x component, how far along in the x direction. B is the y component, how far along the y direction. And c is the z component, how far in the z direction. And this will also be known as ai plus bj plus ck, where I is the unit vector 1, 0, 0 in the x direction. B is the vector 0, 1, 0 in the y direction, and k is the unit vector 0, 0, 1 in the z direction. And if you have a vector is a displacement from one point to another, from x1, y1, z1 to x2, y2, z2, its components are the terminal point components minus the initial point components. x2 minus x1 by y2 minus y1 by z2 minus z1. Okay. The length of v, denoted by length of v, is it's a three-dimensional Pythagoras relation, square root of the sum of the squares of the differences in the components. Fairly standard. Same stuff as two-dimensional vectors, only done in three. And you add vectors by adding components. A, B, C plus D, E, F is A plus D by B plus E by C plus F. A by B by C minus D by E by F is A minus D by B minus E by C minus F. And K times A, B, C is KA by KB by KC. Again, very much like two-dimensional vectors. And very much like two-dimensional vectors, we have a three-dimensional vector dot product. Given two vectors, v and w, at an angle theta to each other, the dot product will be the sum of the products of the components. v1w1 plus v2w2 plus v3w3, and its dot product is also length of v times the length of w times the cosine of the angle between them. So these are two definitions, one arithmetic and one geometric. And from here, this second equation, we immediately get an equation for the angle between two vectors. The cosine of the angle is the dot product by the product divided by the product of the lengths. So, and therefore, we're taking one more step. Theta is arc cosine of v dot w divided by a length of v times length of w. And like in the two-dimensional case, the dot product is commutative. U dot v equals v dot u. It distributes over vector addition. U dot v plus w is u dot v plus u dot w. The dot product of a vector with itself is its length squared. Again, that follows pretty much directly from both this definition and this. And the zero vector dot v is 0. Now, if we take a vector v and divide it by its length, the result is a vector with length 1. So this v over length of v is the unit vector in the v direction. Now, if we have a vector in space, then if alpha is the angle the vector makes with the x-axis, and beta with the y-axis, and gamma the angle the vector makes with the z-axis, then these are called the direction angles. And they are equal to, respectively, alpha is arc cosine of v dot I over length of v, beta is arc cosine of v dot j over length of v, and gamma is arc cosine of v dot k over length of v. And v, the vector v, is its length, v, times cos alpha by cos beta by cos gamma. This vector, cos alpha by cos beta by cos gamma, is a unit vector in the v direction. So, some examples. Find the distance between -1, 2, 3 and 0, -2, 1. Well, okay, that's just be the length of the vector between them. So the length, distance of the square root of sum of squares of differences. -1 minus 0 squared plus 2 minus -2 squared plus 3 minus 1 squared Negative 1 minus 0 is a negative 1. Squared is 1. 2 minus negative 2 is a 4. Squared is 16. 3 minus 1 is 2. Squared is 4. Root of 1 plus 6 plus 4 is square root of 21. 35 asks for the length of I minus j plus k, which works out to the length of 1 by negative 1 by 1. So that's the square root of 1 squared plus negative 1 squared plus 1 squared, which works out to the square root of 3. For 41 and 43, we're given two vectors. V is 3 by negative 5 by 2. W is negative 2 by 3 by negative 2. And the book asks, what's the length of the difference and what's the difference of the lengths? And again, this seemingly grammatical difference does make a difference. So u minus v, well, 3 minus negative 2 is a 5. Negative 5 minus 3 is a negative 8. 2 minus negative 2 is a 4. And the length of that is root of 5 squared, 25, plus negative 8 squared, 64, 16, plus 4 squared, 16. Square root of 25 plus 64 plus 16 works out to the square root of 105. Okay. Here, instead of length of the difference, he'll take the difference of the lengths. Length of 3 by negative 5 by 2 minus length of negative 2 by 3 by 2. This length here is square root of 3 squared plus negative 5 squared plus 2 squared. There, minus. This length here is the square root of negative 2 squared plus 3 squared plus negative 2 squared. After a bit of arithmetic, this comes out to 38 and this to 17. So the answer is square root of 38 minus square root of 17. And again, obviously, these will be quite different. Here we have two vectors. V is 2 by 2 by negative 1, like here. W is 1 by 2 by 3, like here. What is their dot product and what is the angle between them? Okay, the dot product, 2 by 2 by negative 1, dot 1 by 2 by 3. Well, 2 times 1 is 2. 2 times 2 is 4. Negative 1 times 3 is negative 3. 2 plus 4 minus 3 is 3. Dot product of 3. Theta, the angle between the vectors, the arc cosine of the dot product, 3 over product of the lengths. This one has length root of 2 squared plus 2 squared plus 1 squared. This one has length root of 1 squared plus 2 squared plus 3 squared. This works out to root 9. This works out to root 14. So the arc cosine of 3 over root 9 times root 14, which after consulting calculator gives you 74.5 degrees. All right. So, okay, a bit of nice trigonometry, angles of vectors in space. Fairly easy, actually, come to think of it. You just take a dot product, that's easy enough, and lengths and arc cosine. This one, 5-7, is really, there's only a little bit of trigonometry in it. This is mostly linear algebra. So given two vectors, v1, v2 by v3, w1 by w2 by w3, then the cross product is a three-dimensional vector. And okay, as this complicated formula, w2, v2, w3 minus v3, w2, v3, w1 minus v1, w3, v1, w2 minus v2, w1. It's written by this as a 3 by 3 determinant. And no, we didn't cover determinants in this course, but this is how it works out. You'll have to consult other linear algebra texts and courses to get the definition of a 3 by 3 determinant. And it works out to this, as difficult as this is to work out. Geometrically, the idea is simple. We have V and W, then V dot W will be perpendicular to both using what's called a right-hand rule, sweeping from V to W, so it points this way. You sweep from here to here, and your thumb points in the direction of the dot product, or the cross product, excuse me. And its length is length of V times length of W times sine of the angle between them, which is the area of a parallelogram with sides V and W. So we draw this parallelogram. This area will be the length of the cross product. rather different than the sign, than the dot product, which is the which has length of v times length of w times the cosine of the angle. Here's length of v times length of w times the sine of the angle. And it's a vector, not a number. All right. If, for example, u cross u, well, the angle between a vector and itself of the parallelogram spanned by a vector in itself is 0. Or another way to put it, sine of the angle would be sine of 0. And so length of u dot u would be 0. So u cross product, u cross u is 0. The cross product is so defined that if you swap the vectors, you get the opposite result. U cross v equals the opposite of v cross u. This is a very different kind of, this is very different from ordinary multiplication. It's what's called anti-commutative. However, it does have a kind of associativity. A number times u cross v equals alpha u cross v. And it does have a kind of distribution. U cross the sum v plus w is u cross v cross plus u cross w. I'm sorry, I keep on making these confusing dot cross product and sum. I deserve to be honked. All right. Oh dear. Here we have to go over the definition of determinant. Determinant of a 2 by 2 matrix is product along the main diagonal minus product along the opposite diagonal. 3 times 2 minus 1 times 4. 6 times 4 is 2. Here, a determinant of a 3 by 3 is also a bit complicated. It's plus a times the determinant of 3, 5, 0, 2, minus b times negative 1, 5, 5, negative 2, plus c times 1, negative 1, 3, 5, 0. Basically, you do plus this, minus this, plus that, each one times the determinant of the matrix that result from eliminating that row in that column. So for b, it'd be minus b times the determinant of negative 1, 5, 5, negative 2, which is what we have here. And c, we cancel out this row, this column. So it'd be plus c times negative 1, 3, 5, 0. And after a bit of work, this comes out to negative 6a plus 23b minus 13c. Again, this is more linear algebra than it is trigonometry. All right. And so, okay, here we have v is 2, negative 3, 1. W is 3, negative 2, negative 1. What's u cross v cross w? What's w cross v? What's w cross w? And what's v cross v? Well, these last two are easy. A vector cross product with itself is always the 0 vector. And so these are both 0. Here's v cross w and w cross v. So they are opposite of each other. So let's get to v cross w. So ijk times 2, 3, negative 1 here, 3, negative 2, negative 1 here. So be I times this determinant negative 3, 1, negative 2, 1. Minus j, so it's a plus minus plus. Minus j times determinant of 2, 1, 3, negative 1 here. Plus k times 2, negative 3, 3, negative 2 here. And okay, after a bit of work, it's negative 1i minus a negative 5j plus 5k. Or in other words, negative 1 by 5 by 5. Then w cross v is the opposite of v cross w. So the opposite of negative 1, 5, 5, or 1, negative 5, negative 5. And here we have a curious thing, a vector dotted with a cross product, which turns out to equal the volume of the parallelepiped that the 3 vectors span. Well, we proceed. So first this, okay. So negative 3, 3, 2 by 1, 1, 3, okay. Oh dear, I may have made some mistake. Oh no, 3 times 3 minus 2 times 1, first component. For the second component, it's the opposite of negative 3 times opposite of negative 3 times 3 minus 1 times 2. Component for z is minus 3 times 1 minus 3 times 1, which comes out to 7, 11, negative 6. That dot with 2, negative 3, 1 is 2 times 7 plus negative 3 times 11 plus 1 times negative 6. And after a bit of arithmetic, that's negative 25. Okay, now like I say, this one I'm a little disappointed with because it's not really trigonometric. Though, like I say, it doesn't, we do mention sine theta here. Okay, I think that'll do for now.